Hello guys, and welcome back to the show. In the last video tutorial, we saw how to create an HTTP endpoint using HTTP4s, and we saw that this endpoint accepted a post request of type event. In today's video, what we are going to do is to integrate Kafka into our application so that when a person sends a request, the request is published into a Kafka topic, and then we will have a consumer which will consume from that Kafka topic and then store that event into Elasticsearch. If you would like to follow along, look in the video description for the source code for this tutorial. Let's get started and let's see how we can implement this. So what is Kafka? Kafka is basically a distributed data store which is optimized for ingesting and processing streaming data in real time. And when I mean streaming data, I mean data that is continuously being generated by thousands of data sources. It is sometimes used as a means of communication between two microservices. So how does Kafka actually work? There are a few concepts that you need to understand in order to understand how Kafka works. The first concept is what a producer is. The second concept is what a topic is. The third concept is what a partition is. And the fourth concept is what a consumer is. You can think of a producer as a postman, okay? So a postman will basically take your letter, and the letter will be basically the event that has been generated. So if I'm a user on the website and I click on a button, I emit an event, I generate an event. That event is taken by the producer, and the producer is the postman. The producer puts that message into something that we call a topic in Kafka. A topic is basically like a letterbox or a container that contains lots of letters, okay? And the letters are not directed to any specific end user. So when I write a mail, I have the recipient of that mail. When I send the letter, I have the recipient of that letter. But in Kafka, we don't have any recipient. All I do is that I have an event. The postman will take that event, which is the letter, and then put that message or that letter into something that we call topic. That letter is not directed to anyone. We are not specifically sending that letter to anyone. I take a message, which is the event. I put that message into something that we call a topic, and that's it, okay? Inside of the topic, we have something that we call a partition. This is how I like to think about topics and partitions. I like to think of a topic as a box, and inside of that box, I have shelves in it. And each shelf is basically a partition. Shelves contain books, and each book is basically a message that is emitted into that topic. It is basically like sharding in a database. When we want to scale a database, we shard the database. We divide the records into smaller subsections, right? In order to be able to scale it. That is the same concept that we have with Kafka partitions. The last thing that we need to understand is basically a consumer. What a consumer does is that it basically subscribes to a topic, and then it starts consuming the messages that are put inside of the partitions. We have consumer groups, but I'm not going to get into the details of consumer groups. That is out of the scope of this tutorial. But I want you to understand that what a consumer does is that it subscribes to a topic, and then it consumes, it starts eating all the messages inside of the topic, okay? So it will go into each partitions, okay? This partition, that partition, and that partition, and then it will consume all the messages in the partition, and then we can do whatever we want to do with those messages that are consumed by the consumer. Now let's get into how we can actually implement this using code. To work with Kafka, what I'm going to use is a library called FS2 Kafka, which is the functional Kafka streams for Scala. So I will copy this, go into my dependencies.scala file. So I'll go into the dependencies over here. And inside of this place, I will create a variable that I'll call Kafka, and I will assign it this like so. And then I will come over here and create a private variable, and then I'll call it Kafka version or FS2 Kafka version, and I'll specify the version as 2.2.0 like so. And then I will use this in here like so. And the last thing I'm going to do is to copy this and then add this to my build.sbt file. Okay, so I'll say dependencies dot Kafka like so. and then I'll build this. Now that we have added Kafka as a dependency, what I'm going to do is to go into the core directory and then create another package, and I'll call this package Kafka. Inside of this Kafka directory, I'm going to create a trait, and I'll name this trait Kafka Producer Algebra, okay? So I'll say Kafka Producer Algebra, and this will be a trait like so. So this trait will basically define the functionality that our producer should do, which is basically publish to Kafka, okay? So I'll define a method called publish, which will take in an event of type event, and I'll return an F of a unit, okay? And F is basically the effect type, which I can add here, all right? So I'm saying that this Kafka Producer Algebra will have a method called publish, which will take in an event and then return an F of a unit. The next thing that I will do is to actually implement this interface. So I'll create an object, and I'll call this object Kafka Producer Algebra, and I'll define a method called implementation. It will take in an effect type like so, and then what it will return is that it will return a new Kafka algebra of type F. And since this method has not been implemented, I need to implement this method, okay? So I will say def publish like so, and then we need to make sure that effect type has an implicit async. So I'll add async over here. Now, as you can see from the FS2 Kafka documentation, in order to create a Kafka producer, we first need to create a producer settings, okay? And for the producer settings, we need to provide it at least the bootstrap server, okay? And then we need to provide it the serializers. So the key serializer and the value serializer, which will basically be the serializer for the events that we are actually emitting to Kafka. So we'll go ahead and create a key serializer and a value serializer for the event that we actually want to emit to Kafka. Let's see how we can do this. So I'll come over here, and then I'll create a value serializer. So I'll say val serializer, and this serializer will be of type serializer of type F and then event like so. So what we actually want to do is that we want to serialize our event into a string. So we can use a function called control map, okay? So we can say serializer of type F and a string dot control map. And basically what the control map is saying is that, okay, I have an effect type and a string over here, okay? Control map will take in a B, and the B will be the events that we want to actually emit to Kafka, okay? And then it will take in a function that will take the B and then convert that B into an A, which is a string, okay? So that we can have a serializer of F of B. So we will have a serializer of the effect type that we provide, and then a B, which will be the events that we actually emit. So what we can do is that we can say a serializer of type F of a string will be dot control map, and the type for the control map will be event dot as JSON. So we want to basically import IO, the cursor, the syntax like so, so that we can have the as JSON available, okay? So as JSON will give us a JSON, then we can convert this JSON to a string, so we can use the no spaces and we can have a string over here. So this will basically give us a serializer of type F and an event. So now we have our value serializer, and let's actually make this explicit, and let's call this value serializer like so. So now that we have the value serializer, what we can do is to create the producer settings, okay? So I can say val producer settings, and the producer settings will be a producer settings. Then I can pass it the key serializer, and as I said earlier, we don't care about the key serializer in this scenario, okay? So I can say that the key serializer will be a serializer of type F in the unit. What we care about is the value serializer, which is the event that we actually emit. And I can say that the value serializer will be this value serializer, okay? So this value serializer will be this value serializer over here. So I need to also provide the server for Kafka, okay? what port the Kafka broker will be on, okay? And we use that using the with Bootstrap server. And as you can see, the Bootstrap service is basically localhost 9092, which is the default port for Kafka. So I'm actually going to copy this and then paste this over here, like so. And the last thing I'm going to do is to add with Axe. So basically, what the with Axe.1 is saying is that when I publish an event, when I publish a message into a Kafka topic and the message goes into a partition, at least one partition replica should receive the record before the producer can consider the write as successful, okay? Because a partition has got replicas, so that in case a primary partition fails, we have a replica partition which contains the data that we actually emitted into that partition. So the with Axe.1 is saying is that, hey, when I publish an event into Kafka, I want the replicates of the partition, at least one of them, to receive the record before the producer can confirm that the publishing has been successful. I hope this makes sense. So now we have the producer settings and we basically have something like this. Now what we can do is to create a Kafka producer instance, and we can use the Kafka.stream or Kafka.resource, whatever we want, okay? And then once we have created the instance, what we can actually do is to start producing records, and we can do something like this. So I'll come over here, then I'll say that Kafka producer. So let's import this Kafka producer. Then I'll call the stream method on the Kafka producer. Then I'll pass it the producer settings, okay? Like so. Then I'll use the eval map chunk. Then I'll say producer. Then I'll actually create the record that I want to store into a Kafka topic. So I'll say val record, and the record will be a producer record, okay? So producer record represents the record that we want to actually publish into a Kafka topic. So I can say that producer record, and this will be a producer record of type unit, which is the key, and then the value will be of type event, like so. And this will be a producer record, and this producer record will have a topic name, which is the name of the topic that we want to publish our event to, okay? For now, I'll put a string, an empty string like so in there. The key will be a unit, which I'll represent with a unit like so, and then the value will be the event, okay? This event. So I can put this over here. So now we have a record that we want to publish to Kafka. So the next thing that I'm going to do is to actually produce to Kafka. So I can say the producer dot produce, okay? And what do I want the producer to produce? I want the producer to produce 0 or more records to Kafka, okay? I want it to publish 0 or more records to Kafka. So I can say producer records, which is different from producer record. So I can say producer records dot one, then I can pass it the record. And what this produce actually returns is that it returns an F of a producer result. So I can flatten this, okay? So what I'm gonna do is to say the flatten, so that I have just an F. And as you can see, I do not have flatten here. So what I can do is to import cut dot implicit, like so. And I should have flatten now, like so. So what I'm going to do is that once everything has been produced, what I want to do is to print something, okay? Is to print something to the console. So I can say dot eval type chunk, and let me add the console type class over here so that I can print to the console in a purely functional way. Then I can say that console type F for print line, the event has been published, like so. Then I can do dot compile, then dot drain, so that I can get an F of a unit, because I do not want the result of that stream, okay? I just want to publish into Kafka and then ignore the result of that stream. So this is how we basically create the producer in Kafka, and I basically use the documentation from FS2 Kafka. But as you can see, we are basically hard coding the Bootstrap service and the topic in here. We can do better. So what I'm going to do is to create something like we did for the server config in our server tutorial. So what I'm going to do is to create a Kafka config. Since we've done this before, I'll go ahead and implement this, and then I'll show you guys how I did it so that you don't sit around and then wait for me to do this. So I've gone ahead and created a Kafka config. As you can see, the Kafka config takes in a Bootstrap server, which is of type Bootstrap, which is basically a final case class, which takes in a Bootstrap server of type string and extends any val. Okay, I've done the same for group ID, which is basically a final case class. Group ID, it takes in a group ID of type string and then extends any val. And I've done the same thing for a topic. Okay, topic is also a final case class. Topic, which takes in a topic of type string and then extends any val. So the next thing that I'm going to do is to basically go into config here, and then what I'm going to say is that this will take in a Kafka config of type Kafka config, and then what I can say is that Kafka config dot Kafka config of type F, like so. So now I can say par map n, so I'll say import cat dot implicit, like so, and I can say par map n, and then I have the server config. So now I have a server config and a Kafka config, like so. Then I can pass it the Kafka config. So now I have a configuration which has the server config and the Kafka config. The next thing I'm going to do is to go into my Kafka producer algebra, and then I will say that this implementation will take in a Kafka config of type Kafka config, like so. Okay, and I can now use this Kafka config in here. So I can say that I have a Kafka config dot bootstrap servers dot bootstrap server dot bootstrap server. I can also change this to value if I want to, because it sounds more natural to have value over here. So I'll change this to value. Then I can go back to the producer and I can say value. Okay, then I can come over here as well. Then I can say Kafka config dot topic dot value. I know value does not exist yet, so I'll go over here, go into topic, then I'll change this from topic to value, like so. And this should now work as we have it. And if we go back to the Kafka configuration, as you can see, I have another parameter called group ID of type group ID, and this group ID will be used when we implement the Kafka consumer. Now that we have the producer ready, what we can actually do is that we can integrate this to our root. Okay, so what I'll do is to copy the Kafka producer algebra, go into the server, and in here, what I'm gonna say is that I will have a Kafka producer, and this producer will be a Kafka algebra dot implementation. Then I'll pass it an F, which is the effect type. And what I'll do is that I'll pass it the config dot Kafka config, like so. So now I have a Kafka algebra over here, and I think it's right if I only change this to Kafka algebra, or even better, change this to a Kafka producer algebra. So a Kafka producer algebra. So now I've got a Kafka producer algebra, and I want to pass this to the event root so that when a person sends a request, the body of the request, the body of the post request is published to Kafka. So I need to go into the event root, and I'll say that this event root will basically take in the Kafka producer algebra. So I'll say it will take in a Kafka producer algebra of type Kafka producer algebra of type F, like so. And now that I have the Kafka producer algebra, what I can do is that I can say that, hey, when someone posts a request to the /API/v1/event endpoint, what I want you to do is to attempt to decode the body of the request to this type. Okay, if it fails, I still want you to return an error. Okay, check the request body. If it doesn't fail, before you actually return created, what I actually want you to do is that I'll actually want you to pass the event to the Kafka producer algebra. So I can say that the Kafka producer algebra dot publish, and then once it has been published, I want to return created. So publish what? I want you to publish the event. So I can say event, like so, and then I can pass in the event over here, like so. And actually, let me import the cat implicit. So import cat dot implicit, like so, so that I have this app. So basically what this is doing is that it produces this, okay, but what it does is that it ignores the results of this and then return the results of that. So now we have our Kafka producer set up. Let's try and build the application and make sure that it builds correctly. Okay, so it is failing because rightly we have not passed the Kafka producer algebra over here. So what I'll do is to pass the Kafka producer algebra over here like so. And then now let's build it again and make sure that everything passes, everything builds correctly before we progress through the application. So the application is now building correctly and I did not get any compile errors, but we cannot actually test it because we do not have Kafka on our machines, right? So what we need to do is that we need to have Kafka available somewhere so that we can actually test this. In order to have Kafka available, what you can do is to install Kafka on your local machine and then use that to test the application. But that's not what I'm going to do. What I'm going to use is Docker. All right. So I'm going to add a Docker Compose file to our application and have a Kafka and Zookeeper image. And then we can use that to test the application. So what I'm going to do is inside of the root of the application, what I'm going to say is touch Docker Compose.yaml. So we now have an empty Docker Compose file. So what I'm going to do is to add the necessary configuration that I need to basically pull a Kafka image and a Zookeeper image and then connect the ports. Okay, so what I've done is that I've gone ahead and added a Zookeeper image, so the latest Zookeeper image, and then I've added the Confluent Kafka image as well. This depends on Zookeeper, so the port will be port 1992. So we've actually mapped port 1992 in the container to port 1992 on our local machine. If you don't understand how Docker Compose works, I basically have a tutorial on this channel which basically explains how Docker Compose works, so you can actually have a look at that to understand Docker Compose better. So now that we have added the Docker Compose file and the necessary configurations, what we can do is to actually run Docker Compose and then start our application and then see if we actually get this message printed in the console. So what I'm going to do is to go to the terminal. From the root of the application, I'm going to say Docker Compose up. Okay, let's actually check that everything is running. So I can do a Docker PS, and as you can see, I've got Kafka and I've got Zookeeper both running. So I know that everything is running correctly. The next thing I'm going to do is to basically start the server. So over here, what I'm gonna do is to type in SBT, then I'll type in project, then I'll type in event store, and I'm going to type in run. So now we can see that the server has been started. So let's try and send a recurl request to our endpoint again. So in the last tutorial, we created this bash script, which basically sends a request to our endpoint. So what I'm actually going to do is to run this bash script. So I'll say /test server and run this. So we know that the request has been sent. Let's actually check over here. And as you can see, we see the event has been published. So we know that the event has been published inside of the Kafka topic. So now what we are going to do is to basically create a consumer that will basically consume the data, okay? Consume the event that we've actually published into Kafka and also log that to the console. Let's see how we can do that. So just like we created the Kafka producer algebra, what we are going to do is to create a Kafka consumer algebra. So I'll come over here, then I'll create a trait, then I'll call this a Kafka consumer algebra, like so. Now this Kafka consumer algebra will take in an effect type, then it will have one method which I'll call consume. It will return a stream of type F, which is the effect type. Then it will return a commutable consumer record. So I will say commutable consumer record, and the commutable consumer record, it takes in an effect type, a key, and a value. So we can go over here and then tell the commutable consumer record that the effect type will be of type F, the key will be of type unit, and then the value will be of type event. The next thing is to create an object that we will call Kafka consumer algebra. So I'll create an object, I'll call it Kafka consumer algebra, then I'll create an implementation just like we did for the producer. And this implementation, what it will do is that it will take in an effect type. So we'll pass it an async type class and a console, because I plan to log to the console, okay? And then it will take in the Kafka config. So I'll have the Kafka config, and then what I will do is that I'll return a new Kafka consumer algebra of type F, like so, and I will implement the consume method like so. And let me put the annotation for the return type. So the return type will be of type Kafka consumer algebra. Now, if we go back to the FS2 documentation, so for consumers, what we need is that we need to provide it the consumer settings, and we need to provide it a key deserializer and a value deserializer. So I'll go ahead and basically copy this consumer settings, and then inside of the consume method, what I'm going to do is to paste this over here. Okay, so now I have a consumer settings. We know that we don't care about the key, so the key can be a deserializer of type F, and then this can be a unit. Basically, what the key does is that records with the same key are stored in the same partition. But for this project, we don't care about where our record is stored in a partition. That's why for the producer, we define it as a unit, and then for the consumer, we also define it as a unit. For the value deserializer, we need to now have a deserializer for our event type. Okay, so what I'm going to do is to create a value deserializer. So I'll come over here and create a value deserializer. Okay, and what this value deserializer will be is that it will be a deserializer of type F, which is the effect type, and the return type will be of type event, like so. So a deserializer describes a function that takes an array of bytes and basically returns an F of an A. And it says over here that if the deserializer only needs access to the bytes, we can use the lift method, okay? Which is what I'm going to use because we do not need access to the topic. So deserializer dot lift, the effect type is of type F, and then event, and this will basically give me a byte array, okay? And I need to convert the byte array into the event, okay? So what I can do is to use decode byte array of type event, which will basically take this byte array. And this decode byte array is from yarn, okay? So if I do import io dot serce dot yarn dot decode byte array, okay? And this returns an either, so it will try to decode the byte array into the event type that we want, okay? And it will return an either, an error, or an event, okay? And I can actually lift this either into an F. So I'll do import cat dot implicit, then I'll do dot lift to, so I want to lift this to an F. So I'll pass it an F like so. This lift to is basically like saying async dot from either, like so. Okay, that is the base, same concept, but I prefer lift to. So now I have a value deserializer, so I can replace the value deserializer by this. Then I have with auto offset reset, alias is fine. And then we can say that with bootstrap service, what we can do is to pass it the Kafka config dot bootstrap service dot value, and then we can pass it the group ID. So we can say Kafka config dot group ID dot group ID. Actually, let me change this to value as well, and I can change this to value. I'll go back to the consumer algebra, then I'll change this to value. So I don't want to get too much into details of the internals of Kafka, but let me talk about what a Kafka group is. So a consumer group is a group which is made up of lots of consumers, okay? And all these consumers will consume from a partition. So imagine that in a topic, I have 10 partitions in there. and then 5 consumers in a consumer group. Each consumer will basically consume from 2 partitions. So they will all work together in order to consume the messages in the 10 partitions. And consumers with the same group ID will form part of the same consumer group. Okay, so over here we are saying that with group ID, then we've passed it the value, the name of the group ID, and all consumers which have the same group ID will form part of the same consumer group. Now that I have this, what I can do is to name this consumer settings. So I can say val consumer settings, and the consumer settings will basically be this. The next thing I'm going to do is to actually create the consumer, and I can do that by saying Kafka consumer, like so. I'll import the consumer from FS2 Kafka, then I'll pass it the effect type, which is F. The key will be a unit, and then the return type will be of type event. And I can pass this the consumer settings like so. The next thing that I will do is that I will tell it to subscribe. Okay, so I want you to subscribe to a topic. So as you saw earlier on in this tutorial, I said that a consumer will basically subscribe to a topic, which is basically the container which contains the messages, and it will start consuming, it will start eating the messages inside of those partitions in the topic. So I need to tell the consumer which topic to subscribe to. And the topic that I want the consumer to subscribe to is the Kafka config.topic.value. And then I can say .records, which will basically return the records. Then I'll say .eval, tap chunk, consumed record. Then I'll say console of type F, .println, record. And once this has been printed out, what I want to do is I want to commit the offset. Okay, committing an offset is basically changing from one position inside of the partition to another position inside of the partition. So I'll say consumed record.offset.commit. So basically update the position that I am in inside of the partition. And actually, let me print out the record value. So consumed record.record.value, like so. The only thing left now is to use the consumer. So what I'll do is to copy this Kafka consumer algebra, go to the server, and inside of the server, what I'm going to do is to create a consumer. So I'll say consumer for now, and this consumer will be the Kafka algebra consumer. So I'm going to actually change the name to Kafka algebra consumer. So I will import the Kafka algebra consumer dot implementation. I'll pass it the effect type, then I'll pass it config dot Kafka config, like so. We are going to say that, okay, we are basically going to run this Blaze server, and as we are running this Blaze server, what we are going to do is to concurrently run the Kafka consumer. So I'll say dot concurrently Kafka consumer algebra dot consume, and that's basically it. Okay, so if everything was implemented correctly, once we start the application and we publish an event to Kafka, we should actually see record has been processed. So let's try and see if this works. I'll say docker compose app. I'll go on and start my project as well. So I'll type in SBT. I'm gonna say project event store, and I'm going to run. Okay, so we know that the server has started. So what I'm going to do is to run the bash script again. A message has been sent, and as you can see, the event has been published. And what event did we actually publish? This is the events that we publish, because it says the username is Beatrice. The message is this: what I plan to achieve is tomorrow I want to just sleep, and then regrets is basically none. So we know that our application is working as expected. The next thing we are going to do is to integrate Elasticsearch into our application, and we will see how to implement this in the next video tutorial. Thank you guys for watching, and I'll see you in the next video.